Alright, so we're going to be talking about the complete the square technique. I wish I could tell you all of the ways this is useful, but most of them will just come up later when we start graphing these things. For right now, I would just like to point out that it is really difficult to solve things that have an x squared and an x to the 1 at the same time. Really, the only other thing we have is factoring, but some things just aren't factorable. Like this, for instance, there are no two numbers that multiply to negative 105 and add to positive 14. So this is a different technique. It's not quite as easy as factoring, but if factoring doesn't work, this always works. So first thing that you do is that you rewrite the equation, and whatever that number is at the end, you just kind of put it to the side. We're not getting rid of it. We just don't care about it. Then what you do is you think this. You want to think what would have to go right there in order for this expression to be a perfect square. And when I say this expression, I mean this trinomial with, currently an imaginary c. I want this to be a perfect square. By perfect square, I mean that whatever the two factors are, they're the same. So either like x plus 2, x plus 2, x plus 11, x plus 11, you get the idea. So the way we do that is we take whatever b is, in this case 14, and you can write it off to the side or you can just do it in your head. You take b and you divide it by 2. 14 divided by 2 is 7, and whatever you get, you then square, and that is 49. So I'm going to put a plus 49 right here. Now this might seem weird because I just made up a number that I wanted to be in this, and it kind of is. So the way we counterbalance this is that you, whatever number you add right there, you then subtract at the end also. So by adding 49 and subtracting 49 at the same time, I haven't actually changed this expression. I just made it a little bit longer. But the benefit of this is that if you look at this trinomial right here, ignore the last two terms, this trinomial, x squared plus 14x plus 49, can you think of two numbers that multiply to 49 and add to 14? Yes, those numbers are 7 and 7, which means that this factors, these three terms, factor to x plus 7 times x plus 7, or x plus 7 squared. This is where the term completing the square comes from. This is a perfect square because it factors into two of the same things. So the same way that like 64 is a perfect square because it's 8 times 8, x squared plus 14x plus 49 is a perfect square because it's the same as x plus 7 times x plus 7. The last part is the easiest part in my opinion because all you have to do is combine the last two like terms. So negative 105 minus 49 is equal to negative 154. And that's it. Again, we'll talk more about this later, but you notice in our initial problem we had an x squared and an x. Now we only have a single x. And when we get to objective 1.5, you will see that this is way easier to solve for when you only have a single x instead of two different x's with different exponents. Every single time you do this, it's the exact same. I'm going to do two more examples, but you're going to see just how similar they are. So here's another one, x squared minus 40x plus 2. I'm going to start by writing the expression with that plus 2 just off to the end because I don't really care about it. Then I think to myself, what number do I want to be there? Well, I have to take negative 40 divided by 2, which is negative 20. And then I have to square negative 20, which is positive 400. So if I had a plus 400 right here, then this would be a perfect square. If I put a plus 400, then I also have to counterbalance it with a minus 400. And then everything is ready to go. So these three terms right here, the two numbers that multiply to 400 and add to negative 40 are negative 20 and negative 20. That shouldn't be a surprise because that's, we chose those numbers to be that. So this factors to x minus 20 squared. And then the plus 2 minus 400 simplifies to negative 398. So x squared minus 20 squared, x minus 20 squared minus 398. That's it. I'll do one more that looks a little bit uglier just so that you see that it still works the same. X squared plus 5x plus 18. I'll put that 18 off to the side. And then I'm thinking to myself, and you can write this or just think it, I need to get this number by doing b squared, b divided by 2, so that's 5 divided by 2, which is 2.5. and then squaring 2.5, which is 6.25. So I will add 6.25 right here, and then, 6.25, and then I will subtract 6.25 at the end, and then I can start factoring. Now, normally this might be difficult to do in your head, but what two numbers multiply to this and add to this? Well, I know it's got to be 2.5 because I chose it to be like that. So x plus 2.5 squared, you can verify this on the calculator, of course, if you want. And then 18 minus 6.25 is 11.75. And this is equivalent to what we started with, just in a different form. That's it. That's the completing the square technique. If you look at objective 1.5, you'll see where this is going.